Hello and welcome back to the third video in this video series regarding the Intermediate Math League of Eastern Massachusetts. Today we're going to be continuing on with the geometry section. We're going to be learning about triangles again, and then a little bit about algebra-based geometry questions. So let's dive right in. So as you probably know through what I've been teaching you, triangles are definitely the most important polygon that we'll talk about with the geometry section. And we've talked a lot about how we can use triangles to find different angles, especially with the Ngom formula and the triangle sum rule. But today we're going to be talking about specific types of triangles and triangle equality rules. So specific rules that pertain to specific types of triangles. And so there are two special types of triangles that you will need to know for IMLEM. And the first is an isosceles triangle. So an isosceles triangle is defined as a triangle that has two sides of equal length, and then it also has two angles of equal measure. So in the diagrams below, you can see that both of these triangles are isosceles triangles because two of the sides have equal lengths. And the way that we know that is because two of the sides are marked with this symbol right here, a line going through the sides. So whenever you see this line just intersecting, it's not an actual line, but it's just to signify when it's going through two different lines, it means that those lines are equal in length. So on both of these diagrams, we have these lines going through two of the sides, and it's pretty apparent by the figure that these two sides are equal. So it's just representing that those two sides are equal, making it an isosceles triangle. So isosceles triangles also have two equal angles. And so the way to determine which two angles are equal are the ones that are opposite the equal sides. So what that means is if I have this side right here, one of the equal sides, the angle that's on the opposite side of the triangle from it is this angle here. And again, if I have this angle, or this side right here, the angle that's on the opposite side is this angle right here, which means that this angle and this angle, the two that are marked, are going to be the equal angles in this triangle. And similarly in this diagram, this is one of the opposite angles, and this is the other opposite angles, for the angles opposite the equal sides, which means that those two marked angles are the ones that are going to be equal. So a useful fact about triangles, just something about equality rules and summation rules in triangles, is that a triangle can only have one obtuse angle, and it can also only have one right angle. And that makes sense, because a right angle is 90 degrees, and an obtuse angle is greater than 90 degrees. So if a triangle had two angles that were 90 degrees or greater, then that would add up to over 180 degrees, which is impossible, because we know that with our triangle sum rule, that all the angles in a triangle add up to 180 degrees total. It can't be any more, it can't be any less. So if you had two obtuse angles in a triangle, that would add up to greater than 180 degrees, and it's impossible. So that's just an important fact to know that might help you with a few questions. And then the other type of special triangle that we need to talk about is an equilateral or equiangular triangle, but it's more commonly referred to as equilateral. An equilateral triangle is a triangle with three sides of equal length and three angles of equal measure. So we've already talked about regular polygons, and an equilateral or equiangular triangle is just a regular triangle because all the sides and all the angles are equal. So in an equilateral triangle, you don't have to memorize this because you can calculate it, but it's always good to memorize just a few things. We can figure out that all of these angles are going to be equal to 60 degrees. And that's because there are 180 degrees in the triangle, divided by three equal angles, or those 180 degrees are equally distributed among all three angles, which means that each angle has to be 60 degrees for that to be true. Okay, so next regarding what we just learned, we're going to do a review question and move on from triangles, just to talk about some algebra-based geometry questions. So here's a review question regarding the triangles that we just learned about. If you want to try it, I'll give you a few seconds. So you should pause the video now, and then I'll explain the answer. Okay, so the correct answer to this question was that angle ABC equals 40 degrees. So immediately right off the bat, this question seems like a difficult one because you see variables in the equation, or in the question where it says triangle ABC has side lengths x units, and y units. And then if the exterior angle of angle BAC equals 80 degrees, find the measure of angle ABC. So a lot of the time that can be confusing, especially because if you have a complicated question without a diagram, that inherently makes it a little bit harder to solve. So the first two things that we should do is try to change the question to make it a little bit easier to understand, and then draw a diagram to represent the situation. So what I'm going to do is I'm going to read this first sentence right here. Triangle ABC has side lengths x units, and y units. So that's a little difficult for us to understand. But from this, I can take that since two of the sides are x units long, that means that those two sides have to have equal length. Because x is just a variable, it represents some number. Say it represents 5 or represents 10. That means the two sides have to have a measure of 5 or 10 or whatever x is. And that means that those two sides are equal. So that means that this triangle has to be an isosceles triangle if it has two equal sides, as you remember. So what I'm going to do is I'm going to take this first sentence and I'm going to rewrite it as triangle ABC, and I'm going to cross this section out and write is an isosceles triangle. Okay, the triangle ABC is an isosceles triangle. And so next we're going to continue reading on with the question. If the exterior angle of angle BAC equals 80 degrees, find the measure of angle ABC. So that's a little bit complicated because we don't actually have a diagram. So we don't know which angle is angle ABC, and we don't know which angle is the exterior angle of angle BAC. What we do know is it's an isosceles triangle. So using that, we can probably draw a diagram to help us solve the question. So I'm just going to draw a diagram. And I know that the exterior angle of one of the angles is 80 degrees. So with that, I'm going to try to make a triangle that should sort of look like the triangle that is describing to us. Okay, so here are my two equal sides, and then I'll add a third side. And so I know that one of the exterior angles is 80 degrees. So what I tried to do is I tried to draw the diagram so it would make sense and it would look right for one of the exterior angles to be 80 degrees. So I'm just going to label this angle right here as 80 degrees. So when you're solving these questions and when you're drawing diagrams, it's always best to try and draw a diagram that looks the most like what you're solving for. Because I could draw any triangle theoretically and still be able to solve it. But it's a lot easier if I have a triangle that actually looks like the one that the question is describing. So I know that this triangle is triangle ABC. And I know that the exterior angle of angle BAC is 80 degrees, which means that this angle has to be the exterior angle of angle BAC. So the next thing I should do is just label that on the diagram. So this would be point A, this would be point B, and this one would be point C. So now I have my triangle, ABC, with 80-degree measure of an exterior angle. And finally, the question's asking us to find the measure of angle ABC, which is this angle right here. So now the question seems a whole lot more approachable. So we have a diagram, we've simplified the question, so now all we have to do is solve it. And as I've told you before, the easiest way to solve these questions is to work backwards. You want to figure out what you need to know in order to find what you're looking for. So we're trying to find angle ABC. So in order to find angle ABC, since this is a triangle, we know that if we have two other angles, so if we have this angle, and if we have this angle, we can use our triangle sum rule to figure out what the measure of angle ABC is. So our first priority should be to find this angle and this angle. So immediately right off the bat, I know that the measure of angle BAC, not the exterior angle of angle BAC, but angle BAC itself, has to be equal to 100 degrees. Because if you remember our exterior angle rules, the interior angle and the exterior angle add up to 180 degrees in total. So if the exterior angle is 80, then the interior angle BAC in the triangle has to be 100 degrees. So now I have one of the angles in a triangle that I'm looking for. So I'm going to label it right on the diagram. But I still have to find this angle. And I don't know that much about the triangle, so there's not a lot of ways to do that. But what I do know, what they told us in the question, and they must have told us this for a reason, is it's an isosceles triangle, which means that the triangle that we're talking about, triangle ABC, has two angles of equal measure. Well, if one of the angles is 100 degrees, if you remember our rule, this triangle can't have another angle that's equal to 100 degrees, because that would be 2 of 2's angles, and that would already add to 200 degrees in total, which is more than the total amount of degrees that a triangle can have. So I know that the 100-degree angle that I've already found isn't one of the equal angles, which means that the other 2 angles in the triangle, angle ABC and angle ACB, have to be equal. So I'm just going to write that out. Angle ABC equals angle ACB. And I know that this one is 100 degrees. So what I can do is I can find how many degrees are left in the triangle that's not being given to the angle that we already found, and then just divide that by 2, because it's just equally splitting up those degrees among the other 2 angles that I know are equal in this triangle. So what I should do is I should subtract 100 degrees from 180. Find how many degrees are left for the other 2 angles in the triangle. And that's 80 degrees in total. And then the final thing that I have to do is divide that 80 degrees by 2, because I know that angle ACB and angle ABC are equal. That should get me 40 degrees in total. And since I know that angle ABC and angle ACB are the ones that we just found by dividing by 2, angle ABC, what we're looking for, has to be equal to 40 degrees. So the final and hardest section of geometry are the algebra-based geometry questions. And in order to solve those questions, you need to know a little bit about algebra. So before we dive into those questions, I'm going to be going over some algebra basics, which will also help you when we get to the algebra section of IMLEM. So the first thing is a variable. A variable is defined as a non-number symbol that represents a value, such as x, y, z, or even something such as angle ABC. So what that means is when we have a variable, say we have a variable such as x, it just represents a number. So you could say x can be equal to 5, x can be equal to 10, or you might not know what x is. Even in geometry questions, we've already been using variables. Like when we say find the measure of angle ABC, angle ABC is just a variable, because it's just representing the actual measure of the angle. So the way that we use variables is we write them in equations, and we can use algebra to find the value of those variables after we put them in the equations. So let's take an example. If we know that 2 angles, which we call x and y, are supplementary, you could write that x plus y equals 180 degrees to represent the scenario. Because you know that when 2 angles are supplementary, they add up to 180 degrees. So when your 2 angles are x and y, then inherently x plus y has to be equal to 180 degrees. So that's an equation that we can use variables in to represent a scenario. So when we have these variables in an equation, we can actually find the value of the variable by kind of changing up the equation. And that's by doing something called isolating the variable, which means getting the variable on its own side of an equation. So the format of the equation is variable equals some number. And examples are x equals 34 or y equals 27, which in these cases, x would be the variable, and 34 would be some number, or y would be the variable, and 27 would be some number. So you might not always start with an equation that looks like that, but you can change the equation up to get it down to a form where it's variable equals some number. And that's how you find the value of the variables. And then the way that you isolate the variable is by using algebra. So in order to use algebra to isolate the variable, there are a few basic fundamentals of using algebra that you will need to know. They'll simplify the way that you do it, and they'll make it easier to understand why things work. So the first rule that you need to know is the equation equality rule, which says if you do the same thing to both sides of an equation, then the equation will stay equal. So when I have an example listed below, where I have the equation 5 equals 5. It's a relatively simple equation, but it's a good one for demonstration purposes. So the rule says if I do the same thing to both sides of an equation, then it will stay equal. So in the next bullet, I'm adding 3 to both sides of the equation. So on the left side, I have 5 plus 3 equals, on the right side, 5 plus 3. And so 5 plus 3 is 8. So on both sides, it's just going to be 8 equals 8. In the next bullet, I have 5 times 19 equals 5 times 19. In this case, I'm modifying the original equation by multiplying both sides of the equation by 19. So on the left-hand side, it's going to be 95. Now on the right-hand side is also going to be 95, because 5 times 19 is 95. So this seems really simple, but this is the basis in which we use algebra to solve for variables and equations, because the same rule applies to variables. So for example, if I had the equation 8 equals y, and I subtracted 3 from both sides of the equation, then on the left-hand side, I get 5, and on the right-hand side, I would get y minus 3. So my equation would simplify to 5 equals y minus 3 from 8 equals y, but the equation would still be equal, because applying the rule that we knew from above, if we just subtract the same thing from both sides, or do the same thing on both sides, which in this case is subtracting 3, then the equation will stay equal. And then in the next bullet, I'm multiplying by 4 on both sides, where if I have 4 times 8, is going to be equal to 4y, because 8 equals y. So if I'm doing the same thing to both sides of the equation, which in this case is multiplying by 4, then the equation is still going to stay equal, even if I have variables in the equation. And then before we get to actually isolating the variable, there are a few more algebra properties that you need to know. So the first is the commutative property of addition and multiplication, which says that the order in which numbers are added or multiplied does not matter. So in the examples below, we have 5 plus 3 plus 4 plus 2, and that's going to be equal to 2 plus 4 plus 5 plus 3, because even though we're reordering the order in which the numbers are added, it's still going to stay equal. In the next bullet, we have 78 times 43 times 2 equals 2 times 78 times 43. So again, we're just reordering the way in which these numbers are multiplied, but it's not going to matter, because at the end, you're still going to get the same final result for both equations. So you can restructure addition and multiplication equations to do one or the other first. But this rule doesn't apply to subtraction and division. So the order in which you do subtraction and division does matter. But when you have questions like, or when you have an equation like 5 plus 3, you could restructure it to 3 plus 5, and you still get the same answer. That's the commutative property of addition and multiplication. The next thing that you need to know, which is super important, is the order of operations. So in questions, you're going to have these operations like multiplication and division and exponents and addition and subtraction in parentheses. So you have to do some of them before the others. That's what we call the order of operations. So the order of operation is PEMDAS, parentheses, exponents, multiplication and division, and then addition and subtraction, which means that if there's something in a parentheses, you have to do that first. Next, if there's something that has an exponent, you have to solve that first. And then if there are things that are being multiplied, you do that before you solve whatever's being added or subtracted. And so with PEMDAS, you have to remember that in all equations, because it's very important that you make sure you do the right things first, or it will change the answer to your question a lot of the time. And then the final rule, which is super important, is the distributive property. So the distributive property says that a number multiplied by an expression in a parentheses can be distributed, which is a little bit confusing, but what that means is if, for example, I had x plus 5, which is an expression in a parentheses in the example below, and you're multiplying it by 3, so that's what that means. When you have 3 right next to the parentheses, it means that whatever that number is, you're multiplying it by whatever's in the parentheses. You can distribute that multiplication to multiply by each individual term, which means 3 times x plus 5 could become 3 times x plus 3 times 5. And so in the end, that gets me 3x plus 15. And that's really, really good because you simplified the equation from 3 multiplied by an expression just to 3x plus 15. And so the distributive property is used a lot of the time to simplify equations so you can then work with them, and it makes it a lot easier to find the answer to a lot of questions. So we've been talking about isolating the variable, but before we did that, we had to go over a few basics of algebra to understand how to actually do it. So to isolate the variable, you have to first move all the variables to one side of the equation and all the constants to another. And a constant is just a number like 2 or 5 or 7, or just a whole number that's not a variable. So in the example below, we start with an equation, 3x plus 2 equals 5. So the way that we first get all the variables on one side and get all the constants on the others, we have to recognize that if we have 3x plus 2 on one side, we want to get that plus 2 out. We don't want it on that side. We just want to leave it as 3x. And we want to move that to the other side of the equation somehow. So this is where our equation equality rule is very important, Because what you have to do is you have to do some operation to both sides of the equation in order to get rid of whatever you're trying to get rid of. So in this case, we're trying to get rid of the plus 2. So if we do the opposite operation and subtract 2 from that side, on the left-hand side, it becomes 3x plus 2 minus 2 equals, and then we have to do the same thing on both sides, subtract 2, 5 minus 2. And that simplifies to 3x equals 3. So the reason that we decided to subtract 2, which might be confusing, is because we're adding 2 originally, and we want to get rid of that added 2. So the opposite operation of addition is subtraction. So if we add 2 and then subtract 2, that just ends up with 0. So if we have 3x plus 2 and we subtract 2 from it, it just leaves us with 3x. And then we also have to do that to the other side of the equation. So it's not 3x equals 5, but it's 3x equals 3. So in order to isolate the variable and determine what operation and what number you have to use, you just have to do the opposite operation of whatever you're trying to get rid of. So we were trying to get rid of a plus 2, so we did minus 2. So now that we have 3x equals 3, or all the variables on one side of the equation and all the constants on the other, we have to simplify the equation so there's only one. So some variable equals some number. As you'll remember from our equation, or from our example before on the different slides, when I was telling you how to isolate the variable. So the way that we do that is 3x means that we're multiplying 3 by x. So again, in order to get rid of the multiplying 3, we have to divide by 3, because multiplication is the opposite operation of division. So if we're multiplying x by 3 and then we divide it by 3, that just leaves us with 1x. And again, we have to do that to the same, we have to do the same thing to both sides of the equation. So on the right-hand side of the equation, we have to divide 3 by 3 to get that x equals 1. And so again, the reason that we had to do that is because if we have 3x and we divide it by 3, that leaves us with x. And if we have 3 divided by 3, that leaves us with 1. And that's how you isolate the variable. So step number 1 is to get the variables to one side of the equation and the constants on the other. And then the second step is just to simplify the equation. So you're left with variable equals some number. So that's all the algebra that you have to know to solve these algebra-based geometry questions. But before we actually get to the questions, I'm going to give you an algebra question to try, because it's really important that you need to know how to solve these in order to actually successfully complete those questions. So if you want to try this question, I'll give you a few seconds to pause the video, and then I'll explain it after that. So the correct answer to this question was that x equals 2. So this is an algebra question. So in order to solve it, as you'll remember, I've been saying this a lot, isolate the variable. So we want to leave the equation like I just wrote it, where it's x equals some number, or variable equals some number. And so if you'll remember from isolating the variable when I was talking about that, the first step to isolating the variable is to get all the variables on one side of the equation. So our equation right now is 5x plus 1 equals 11. And on the left side, I don't want that plus 1. I just want it to be 5x, because then I'll have all the variables on one side of the equation. So I need to get rid of that plus 1. So the way that I have to do that is, since it's a plus 1, I have to subtract 1 from both sides of the equation. Or in other words, I have to do the opposite operation to get rid of the plus 1. If I change my equation from 5x plus 1 equals 11 to 5x plus 1 minus 1 equals 11 minus 1, because again, I have to do the same thing on both sides of the equation to make it stay equal, then what I'm left with is 5x equals 10. And then now that I have 5x on one side of the equation, I've almost isolated the variable. All the variables are on one side and all the constants are on the other. The next step, if you'll remember, is just to simplify the equation, so you're just left with the variable equals some number, or x equals some number, not 5x, but just x. And so the way to do that is, since it's 5x, it means that x is being multiplied by 5. Well, the opposite operation of multiplication is division. So in order to get rid of the 5, or the coefficient, that's what we call the number right next to a variable, which in this case is 5, I have to divide by 5, because 5 times x divided by 5 is just going to equal x. So on the left-hand side, that changes my equation to 5x divided by 5 equals, and then the right-hand side, I have to do the same thing, 10 divided by 5. And so 5x divided by 5, as I just said, is x. And then 10 divided by 5 is 2. And so that's the way that you solve these questions. First, you have to make sure that all the variables are on one side and all the constants are on the other, which usually involves doing a bit of addition or subtraction. And then you have to make sure that you actually isolate the variable down. So it's just variable equals some number. And in this case, x was equal to 2. So now we're moving into the algebra-based geometry questions. And you could probably figure these out, the things I'm about to tell you. But it's also good to memorize them to make your solving the question a little bit faster. So first, the supplement of an angle x, so if x is our angle, can be represented by 180 minus x. Because I know that if x is our angle, the supplement of the angles, whatever gets me from x to 180, because the two angles together would add up to 180. So in order to find that supplement, you just have to subtract x, whatever your angle is, from 180. And similarly, the complement of an angle x can be represented by 90 minus x. And that's for the same reasons, because complement is when two angles add up to 90 degrees. So 90 minus x, if x is your angle, will give you the complement of that angle x. And then another rule is that the supplement of an angle will always be greater than its complement. And then before we get into the questions, I just wanted to go over the distributive property again, because you're probably going to have to use them for all of the, or almost all of the algebra-based geometry questions that you encounter. So this is an example of the distributive property, where if you have 3 times x plus y, where x plus y is in parentheses, you can distribute that multiplication to each individual term. So in this case, you can distribute 3 times x and plus 3 times y to get 3x plus 3y. So you can use the distributive property to simplify what's in parentheses. And that's going to be really important to remember when you're actually doing these questions, because you're probably going to have to use it for every single question, or almost all of them at least. So now that we learned all the algebra basics and algebra-based geometry basics in order to solve these questions, it's time that we actually try a question. So this is what a typical question would look like for your algebra-based geometry ones. And if you want to try and solve it, I'll give you a few seconds, and then I'm going to explain how to find the answer. So the answer to the question was that x equals 45 degrees. And so it's a complicated question, but you have to use algebra to solve it. And so what we want to do is use our skills with changing equations to find variables in order to find the value of x. So let's go through the thought process to understand how you actually turn this question into an equation and then find the value of the variable that you're trying to find, which is x in this case. So the first thing that you should do is write an equation that represents the situation. So here's our equation below. 3 times c equals s. So what that means is I wrote c to represent the complement of the angle x, and I wrote s to represent the supplement, because it says the supplement of an angle x is 3 times the complement of an angle x. So in that case, 3 times the complement should equal the supplement of that angle. So this is my equation that represents the scenario. 3 times c, which is our complement, equals s. So the next thing that I should do is I should substitute in calculable values. And so what that means is I'm trying to find the value of x. It doesn't really help if I have c or s in the equation, because I'm not going to be able to find those if I don't have a value that I can calculate. And so what I want to do is substitute in values to represent or replace c and s. They'll be equal to them, but have x in it, because I'm trying to find x. So if you remember, the complement of an angle can be represented as 90 minus x. So that's what I put in the parentheses right here. And then the supplement of an angle can be represented by 180 minus x. So that's what I put in the parentheses on the right-hand side to replace c and to replace s. So the third step that you have to go through in order to find the value of x, and this is when the algebra comes in, is you have to simplify the equation so you can use the equation equality rule in order to isolate the variable. And the way that we do that is we have to use the distributive property to simplify the equation so we can actually do that. And so in this case, we use the distributive property on the left-hand side of the equation, where we have 3, which is a constant, being multiplied by an expression in a parentheses, which is 90 minus x. So the distributive property says you can multiply 3, or whatever's outside the parentheses, by each individual term in the parentheses. So in this case, we turned 3 times 90 minus x into 3 times 90 minus 3 times x. Or in other words, 270 minus 3x. And then since we didn't distribute it on the right-hand side of the equation, the right-hand side stays equal. So now our equation tells us 270 minus 3x equals 180 minus x. So and then the next step is just to simplify the equation using the equation equality rules that we already knew about. So I didn't actually write out the exact steps here, but I'll show you what I'm doing. So the first thing that I do is I want to make sure that I have all the variables on one side and all the constants on the other. So in this case, I chose the right-hand side in order to put my variable on. So that means since in this equation, I have 3x or minus 3x on the left-hand side, I want to get rid of that. I want to make it so it just has 270 on the left side because I want all my variables to be on the right-hand side. I don't want any of them to be on the left. So in order to get rid of the minus 3x, again, I have to do the opposite operation and add 3x to both sides of the equation. So add 3x here, and then add 3x here. So on the left-hand side, 270 minus 3x plus 3x simplifies just to 270. And on the right-hand side, 180 minus x plus 3x simplifies to 180 plus 2x. So now I have this equation, 270 equals 180 plus 2x, but I still haven't gotten the variable on its own. And in order to do that, if I want it on its own, the right-hand side of the equation, I have to get rid of this positive 180 right here. And so there's no actual operation that you can see, so it's hard to figure out which operation to use to get rid of it. But since this is a positive 180, it's just like you're adding it. So in order to get rid of it, I have to subtract 180 from both sides of the equation. So I'm just going to write that out here, minus 180 and minus 180. So on the right-hand side, I have 180 minus 180 plus 2x. And so that simplifies just to 0 plus 2x, and then at the end, just 2x. And on the left-hand side, I have 270 minus 180, because remember, I have to do the same thing to both sides to keep the equation equal. And so in this case, 270 minus 180 equals 90 degrees. So finally, our equation is a lot more simple and left with 90 equals 2x. And then the final thing I have to do is I have to divide by 2 on both sides of the equation. So on the right-hand side, I have 2 times x, but I just want it to be x. So in order to get rid of a multiplication, you have to use division. So I'm dividing by 2 on both sides of the equation. So on the right-hand side, I'm left with x, and on the left-hand side, I'm left with 45. So my final equation is 45 equals x. And that's how you use algebra and use these algebra-based geometry questions to find the value that you're looking for. So we started with the word question, and what you should always do is write an equation that represents the situation, put calculable values in, or the value that you're trying to find, or the variable in this case, which is x, and then use algebra just to simplify the equation down, so you get something like this, x equals 45. So I hope this lesson was helpful. It's by far the most complicated geometry lesson that we're going to go into, because it actually uses algebra, which is a more advanced subject. But we learned a lot about algebra basics, we learned a little bit more about triangles, and I really hope it's helpful and you can apply this into your IMLEM solving.